Hello, it's that twat that's at your pass group, or makes you turn up to the pass group, the bastard. Yep, it's me, and I've received a few queries about objects in Java, and I thought this would be a perfect opportunity to break out a completely arbitrary example that doesn't make any sense, but it's in no way related to shapeshifting, so I won't get sued by John Lathan. Alright, so the purpose of this exercise, to find out if you actually want to go through it, is I'm just essentially going to take you through the basics of instantiating objects, kind of what it means to be an object, I suppose, in kind of a very fundamental sense, and what you can do with objects, the kind of uses of an object. So what's the noddy example I'm going to make you suffer through today? I'll show you the pseudocode. The pseudocode is we're going to make some surfers, we're going to make some sharks, and I think you know what's going to happen when the surfers meet the sharks. There's going to be some chomping going on. Okay, so how do we get started with this? So thinking about the structure of our code. First of all, what's this? This is our main method. In Java, this is the entry point into your Java executable. It's static because there's only ever one instance of the main method. We'll touch more on static as we go forward. If you're not familiar with that keyword, give a few more examples. But essentially, yeah, this is where the execution starts for your program. So we can think of this as the start point, which I'm sure you're already familiar with, just going over the basics here. Okay, and then what's the pseudocode of our program? So we want to make some surfers. Now, what does it mean to make some surfers in Java? It seems like each surfer dude would kind of be their own thing, right? Each surfer dude is independent of one another. They're a separate instance or entity of surfer dude. We're going to use the word instance because ties quite nicely to the language structure. So over here, oh ho, hey ho, we've got a public class surfer dude. Okay, so if I want to make a surfer dude, if I want to take this class and use it to create a surfer dude, how would I do that? So the best way to think of a class is it's kind of like a stamp for something. So what do you do with a stamp? You dip it in the ink, you splot it down, and you've created a new instance of that stamp based on the imprints of this of the stamp itself. And that's kind of the premise for object-oriented programming. The class is kind of encapsulates what it means to be that object, and then using that definition you can stamp out separate instances of it. As I show you, it'll get simpler. Okay, so let's start off. What do you need to create? What is kind of the definition for stamping something? That is the constructor. So in our case, it is public surfer dude. This is the constructor that makes our surfer dudes. If you don't define one of these, then there is an implicit one that is called automatically. So, okay, how do we use that to create our surfer? Okay, so we want to make two surfers, let's say. We want to make someone called, I don't know, let's do it here, surfer. So the first part is the type, so we're making, oh, it's surfer dude, isn't it? I had to come up with the fancy names, didn't I? Okay, so the first part is surfer dude. That's just the name of the type. And then, I don't know, bodacious equals, I recommend, while we're here, probably come up with better variable names than this. Equals new surfer. I apologise for my slow typing. This is a new keyboard. Okay. So we compile this. Compile. Run. Oh, just to kind of explain my layout, by the way, this is Emacs. This is just the editor I use. It's basically Nano, but actually usable at scale. So we have the main. These are all different files. We've got a main file here. We've got a surferdude.java here. Shark.java. It says at the bottom actually. Highlights. Woohoo! Highlights up here. So surferdude.java and main.java. And this is just the terminal running in my text editor to make things a bit easier. I don't have to swap between windows, do the old window dance. Always unpleasant. Okay, so we've created a new surfer dude here. What this is essentially doing is going through calling this very dense method here. It's getting a lot done in these two lines. But yeah, let's try and expand on what does it mean to be a surfer dude? Well, a surfer dude, for my money, is made up of something called meaty chunks. We can go back and forth on this, but it's scientifically proven that surfer dudes are comprised mainly of meaty chunks. So here we have a private int meaty chunks. Now, how does this fit into our template? Every time we stamp a new instance of surfer dude over here, they have a different number of meaty chunks for each of them. So for example, if we make it so the constructor takes a value of meaty chunks, so in meaty chunks, and then we do say meaty chunk. I apologize for my slow typing. It's an ergonomic keyboard. It's confusing to my brain. So yeah, meaty chunks equals in meaty chunks. We're now setting the value in this. We're now taking the value that's getting called in this method and sticking it in here. And for each surfer dude, they can now have a different number of meaty chunks. Now the fact that this is private means that only things inside this class can touch it. So it means if I'm in the main function over here, say, in fact, let's see what happens when we try to compile this code here. So it doesn't compile. Now why is that? It's because constructor surfer dude and class surfer dude cannot be applied to given types. And the reason for that is it requires an int argument. If you specify constructor, then that is that essentially overrides the default constructor and makes it no longer available. So this is no longer available. I now have to pass in an int to get this to work. So now if I run javac, I was about to say java.java, that'd be a very bad class name. We now have created our server dude Bob Bodacious with 1 meaty chunks. And just to kind of illustrate this point, let's make a function, a public int get meaty chunks, which is just going to return return meaty chunks. So now if we do the old favorite from Hello Mum, the classic program, Bob Bodacious .get. Aha! How's this guy going to work? Well, javac main.java, java main. No! No command line! That's not what I wanted you to do. I wanted you to do that. Okay, 1. It's because we've created a surfer dude with that number of meaty chunks. We're getting the meaty chunks, which is returning 1. Printing out the 1. Hey ho, jobs are good. What happens if we create another surfer dude? So here we're creating Bob Bodacious and printing him out. What if we do this? James Muck Surfboard. You know, that's going to be very hard. Other dude. He was blessed with a lovely name. Poor sod. Okay, so this guy, he's got 2 meaty chunks. He's slightly better off in the chunks department. What happens now? Say if I call println other dude get meaty chunks. What happens now? Okay, so first of all, we've created other dude. For some reason, we created him first. Other dude was the first dude. It's a confusing timeline. Just stick with the law. It's going to be good. Which is calling through this constructor, giving him 2 meaty chunks. We then create Bob Bodacious, going through this constructor, creating 2 meaty chunks. These are 2 completely separate instances of memory. So other dude and Bob Bodacious, if you were to, say, print out their location in memory, it'd be completely different. We're then printing out Bob Bodacious, which should print out his meaty chunks, so we should see 1, and then we're printing out other dude's meaty chunks, which should show us a 2. So let's go. And there we go, 1, 2. So Bob Bodacious is 1, other dude is 2. I've inverted the order here just to kind of show you that one isn't overriding the other. They are 2 completely separate instances that don't interact with each other. They simply share the same definition in the same way that, you know, surfer dude essentially is an object in Java, in the same way that a string is an object in Java. These are all, but they're all totally different instances of, say, surfer dudes. I think I made it a bit confusing at the end, but we'll stick at it. Okay, so now we get to do the fun stuff. We get to do the shark. So first we need a constructor for said shark, right? So just a simple default constructor, simple as can be. But what makes up a shark? So I would say the main thing that decides the scariness of a shark when you're a surfer dude is the number of teeth. So what we're going to do is we're going to make a private variable. Oops, no cap for variable names, lower camel case. I know the Java lingo. Have faith. And then this is also going to take in a number of teeth. Okay. I just pressed a bad key in... Okay. The problem with Emacs is it's got about 1 million commands, so if you accidentally press the wrong key, it could just blow up your computer. But that's the risk you take for the niceties of Emacs. Also, it crashes a lot, but you know, nothing's perfect. Okay, if we spell it right. So here we've got a similar constructor to the surfer dude. We could also, you know, public int get number of teeth. Isn't it fun when I'm saying what I'm typing that you can easily see? Yeah, so then get return number of teeth, and then we can do a shark Jaws X. I hope they make a Jaws X film. I was about to type new Jaws. If only it was that easy to make a new Jaws film. Actually, considering Jaws 3 and Jaws 4, it's probably a good thing it's not that easy. So this is going to give the shark 3 teeth. It's a shark retirement home, I guess. System.out.println Jaws X.get number of teethy teeth. Okay, and now one habit you want to get into is you want to compile as much as possible because you'll catch errors as fast as possible. So as you can see, I'm compiling constantly, not just to kind of illustrate what I'm doing, but just because it means I'm going to catch some errors a lot quicker. So as you can see, 1 for the surfer dudes, and then 3 for our lovely new shark over here. Yum yum. Okay, so the next step is we'd really like it if a shark could eat a surfer dude, right? So what do we need for that? Well, when a shark eats a surfer dude, they're going to chomp it. That's a given. And depending on the number of meaty chunks for that surfer dude, we'll decide how many chomps it takes to eat them. So, okay, sounds cool. What about a chomp? Now, I'd say, just in my general opinion as a shark scholar, of course, that sharks all have kind of a similar chomp noise. So for that reason, we're going to use the static keyword here. And the reason we're using the static keyword here for the chomp noise is because every single shark in the whole sea chomps like that. They all make just a chomp noise. Now, because we don't want anyone to change this, we're going to make it final. That means this can't be changed after instantiation. And the fact that it's static means that every single shark shares the same chomp noise. So if we did make this, say like that, and a shark changed this chomp noise, it would change for every shark, which is why generally it's good to make static things final. This is just the normal Java notation to make this capitals. Okay, so there you go, you got your chompy chomp. And this is, as I said, there's only one instance for this. It's more efficient in memory. They all reference the same chomp noise. I think it's more efficient in memory. I don't remember how Hotspot fully works, but essentially there's one chomp noise for every shark. Okay. Now we also need to add a bit of maths here. Actually, we'll leave that for a second. We'll just go down and we'll define the good stuff. Eat. And this takes a surfer dude in dude. What's going to happen is our Jaws X over here is going to eat other dude. No, other dude! You were such an original dude! You were the original dude. Okay, that compiles good. You see what I'm doing here? Checking it compiles at every step. So at the moment, this is calling this... For Jaws X's instance of this class is calling eat with the surfer dude other dude. So okay, what does that mean? So first we need to work out how many chomps it's going to take to off other dude. So chomps to consume equals... So what are the chomps to consume equals? Let's say it equals the in-dude dot get meaty chunks. So the number of meaty chunks for a dude multiplied by some random... Well, not random, obviously. It's a magic number here. Constant. Now, when you have a number like this that's just kind of sitting in the code with no kind of name or string attached to it, it's really good to pull it out into what is called a... to avoid it being sort of a magic number. Because if someone reads this, they're just like, 10? Is that meant to be there? Is that a bug? But if you stick it up here, you go private static final int, similar to our string, chunks to chomps ratio equals 10, and then we stick that here instead. Maybe go for a shorter name in your case. They're now like, oh, it's the chunks to chomp ratio. Chunks to chomp ratio, not chomps. Chunks to chomps. I guess that works. Instead of it just being some magic number floating in the ether, we now have a name attached to it, and we can understand exactly. I should stop clapping. It's not helping you at all. We now know exactly where it's come from. Okay, so we've got the number of chomps, so now we do a simple while loop. While chomps to consume is greater than 0. That's just Emacs being a twat, indenting like that. Sorry. It's not okay, Emacs. It's not okay. We then want system. So when they get chomped, the typical chomp noise. We're assuming for this this example that the surfer dudes are completely mute. If I was a surfer dude and I got bitten by a shark, I'd be screaming like shit. But these are very po-faced, sturdy, hardy surfer dudes. They're very willing to get chomped. And the important thing is to make sure this isn't an infinite loop by actually deprecating by the number of teeth of a shark. So the more teeth a shark has, the less chomp it takes to devour the meaty chunks. It's just simple mathematics. Didn't you do it at school? Come on. I apologise to anyone that isn't a shark scientist in the audience. But trust me, this is 100% shark science right here. So now if we compile this, then we run it. Hey ho, what's this I see? Chomp, 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 chomp. So we've got 1, 2, 3, 4, 5, 6, 7. Now does that add up? So other dude, he's got 2 meaty chunks. So with our chunks to chomp ratio, that's 20 chomps to consume. So we go to 20, we print out the first chomp noise. We then deprecate by the number of teeth that the shark has, which in Jaws X's case is 3. So we go down to 17, print once. We go to 17, or maths now, 14, 11, 8. 7 looks right to me. I'm not going to jump through step by step. But let's say we have shark, Jaws X Junior. Oh shit. This shark has got 300,000 teeth. Now Jaws... Oh, no caps please, let's control ourselves here. That should be a little R really. Ah! Dot eat. And we're eating poor Bob Bodacious, who was only a 1 chunk man. Let's up him to 100 chunks. Imagine he's the size of a small aircraft carrier, Bob Bodacious, but he doesn't stand a chance, unfortunately. God, we're making a new Sharknado movie in code, and people say this is boring. Look at this. Look at this shit. Boom. Actually, just to make it clear where one surfer dude ends and the other begins. Clear the beach! We're all gonna die! There we go. Okay, so now you can see you've got your first chomps for Jaws X here, and then Jaws X Junior jumps on the scene and just swallows Bob Bodacious in a single gulp. So what have we learned from here? We've learned not to fuck around with Jaws X Junior. We've also learned that individual sharks with... Okay, let's take the sharks out of it. For individual classes, a class is kind of like the definition of what your objects want to be. Then by using the new keyword, you can create a new instantiation of that object, completely separate in memory for another one, from another one. So here we have another dude and Bob Bodacious, and they're 2 completely different surfer dudes with different meaty chunks, which, as you can see, is useful because then we can have a shark eat different guys, produce different results. I mean, taking all the kind of surfer dude stuff out of it, these are just kind of data structures at the end of the day. Data structures with definitions on what you can do with them, the behavior that they represent. So in a shark we have the eat function, which is a behavior that is characteristic to all sharks. However, each shark, because they have a different number of teeth, will take a different number of chomps to consume the in-surfer dude. Now, of course, because we're not changing the state of the surfer dude in any way, a shark could just eat a shark. I mean, a shark could just eat a dude if they hadn't already... if they if they'd already been eaten. So one thing we could do is add like a bool to Surfer Dude saying, is totally chomped. And if they've been totally chomped, another shark can't chomp them. But yeah, that's kind of a rough introduction to objects. Now, one final thing I want to mention is, what if you want to make a class, similar to this main class, say, where you don't want people to be able to instantiate it? Well, that's quite simple as well. You simply do this. So what I'm saying here is I've made the constructor private, so only things inside this class can construct this object. Private means it's not accessible to members outside of this class. So in this case, you will not be treated to multiple instances of main, which is what we want, right? Because we don't want more. Well, we couldn't anyway because it's a static function, but it doesn't make sense to create an instance of main because it's not really like a concrete thing in the world, is it? Or something we're going to use. It's just a function that gets called on entry point at the program. So hopefully this has been somewhat helpful to your Shapeshift stuff. Maybe. If you have any more questions about sharks, or because you can see I'm very knowledgeable about sharks, or maybe even programming, you know, if you just want to fucking go wild, feel free to post them in the past group and we'll try and help you out. But yeah, chomp chomp. Good shit.